continuing on with writing equilibrium expressions for acid-base reactions. Instead of dissolving an acid in water, what if we were to dissolve a base in water? So what if we were to take the conjugate base from this reaction and dissolve it in H2O? A minus plus H2O. We would draw a beaker for this situation. So once we put our A minus into this beaker, we know that H2O is our liquid solvent, and this is now aqueous. So when we go to predict the products for our reaction, we can see that A minus does not have a hydrogen to give. Therefore, it has to serve as our base. H2O, while we saw it behave as a base in the reaction prior, in this reaction, it's actually going to act as an acid. So water can act as an acid or a base. So what are our products going to be? So we have H2O in this beaker. The A minus is going to come in contact with it. And instead of the water accepting a hydrogen, what we're going to see is a lone pair on this A minus. You can draw an arrow right from the minus. It's technically a lone pair. Getting good at formal charge and recognizing the charges on acids and bases is an important skill. So I suggest looking over formal charge, very intro to general chemistry. So we can take a hydrogen from that acid. We will now have HA. This will be aqueous. It's still in our water solution. And what is left of our water? Well, we lost a hydrogen. So we are now left with OH minus. And if we see how that works, we can say this was our water with our lone pairs, and we are reacting it with a base. This will take, and this will become a lone pair. So now this water becomes hydroxide with 3 lone pairs on it, which is why we see a minus charge. So we get to put our aqueous sign in front of our OH minus. So this is our reaction for a base reacting with water, which is actually acting as an acid in this reaction. This is going to produce HA and OH minus, so we should finish up by labeling what's in our reaction. So we have a base and acid. Once our base grabs a hydrogen from water, it is now the conjugate acid. And once water acts as an acid and gives away a proton, it is now the conjugate base. So if we want to write K for this reaction, K is going to equal products over reactants. So this is going to be HA times OH minus over A minus. Now, when we react a base in water, and water is acting as the acid, which is giving a hydrogen to our base that we're dissolving, we call this KB. And this tells us that we are dissolving this base in water, and our products are going to be hydroxide every time, and the conjugate acid of whatever base we are now giving a hydrogen to. So now I have covered how to write a Ka and a Kb expression for an acid going into water and a base going into water.